Have you ever wondered what happens when an atom gains an electron? Let's explore the concepts of electron gain energy and electronegativity, essential to understanding atomic behavior and bonding. Electron gain energy, or ΔEEG, is the energy change that occurs when an electron is added to a gaseous atom. For most atoms, this process releases energy, making ΔEEG negative. For example, adding an electron to a chlorine atom releases 349 kilojoules per mole. The negative sign indicates energy is released during the process, making the atom more stable. Interestingly, not all atoms release energy when gaining an electron. Some, like beryllium and nitrogen, have positive electron gain energy. This happens because these atoms already have stable configurations: beryllium with a filled s superscript 2 orbital and nitrogen with a half-filled p superscript 3 orbital. Adding another electron introduces repulsion, making the process energy-intensive. Now, let's look at periodic trends. Electron gain energy becomes less positive across a period as the nuclear charge increases, making it easier to attract electrons. However, moving down a group, ΔEEG becomes more positive because the outer electrons are farther from the nucleus, and shielding effects reduce the attraction. Electron gain energy is closely related to electron affinity, which is the energy change when an anion loses an electron. The relationship is simple: ΔEEG equals electron affinity, EA. For example, when Cl loses an electron affinity is equal in magnitude and opposite in sign to ΔEEG. Next, we have electronegativity, a measure of an atom's ability to attract electrons in a molecule. Linus Pauling introduced the widely used Pauling scale to quantify this property. Across a period, electronegativity increases due to higher nuclear charge, while it decreases down a group as atomic size increases. Even noble gases, which are generally unreactive, have small but non-zero electronegativity values. The difference in electronegativity between two bonded atoms determines the nature of the bond. A large difference leads to ionic bonding, while a smaller difference results in covalent bonding. So, to summarize, electron gain energy measures the energy change when an atom gains an electron. ΔEEG trends across the periodic table help explain atomic behavior. Electronegativity measures an atom's ability to attract electrons and influences bond type. Understanding these properties unlocks the mysteries of chemical bonding and reactivity. Thanks for watching. If you found this video helpful, give it a like, share with fellow chemistry enthusiasts, and subscribe for more Science Explained.